This is first example problem in the title Poisson distribution. The number of monthly breakdowns of a computer is a random variable having a Poisson distribution with mean equal to 1.8. Find the probability that this computer will function for a month. Subdivision A without a breakdown, subdivision B with only one breakdown, and subdivision C is at least one breakdown. The number here, capital X, is the random variable having Poisson distribution with mean lambda. Lambda is given 1.8. The three subdivisions we should first know. Here, breakdowns means capital X, the count, and without means 0, exactly 1 means equal to 1, and at least means greater than or equal to 1. Now, solution part. First, we write capital X as the number of breakdowns of that computer in a particular month, and X follows Poisson distribution with mean, that is lambda 1.8. Probability mass function we know for Poisson distribution, it is e per minus lambda, lambda power r by r factorial. And here lambda is given, so replace it by 1.8. So we have to find each of the case by applying this formula. First subdivision A without breakdown, that is x equal to 0. So instead of r in the right side, we apply 0 at each place. So p of x equal to 0 is now e per minus 1.8 into 1.8 power 0 by 0 factorial. 1.8 power 0 is 1 and 0 factorial is also 1. So we have to just find e per minus 1.8 only. If we evaluate using either calculator or even Android mobile, the answer is up to 4 places 0.1653. So P of x equal to 0, that is without breakdown, the answer is 0.1653. Now subdivision B with only one breakdown, that means x equal to 1. So in the same manner, we write instead of r, we have to enter 1. So we have to evaluate e per minus 1.8 into 1.8, which is 0.2975. So with exactly one breakdown, the probability value is 0.2975. Third subdivision is with at least one breakdown, x greater than or equal to 1. At least one breakdown means minimum one breakdown may occur. The maximum limit is not given, so we write p of x greater than or equal to 1, which means we are taking at each point 1, 2, 3, all the counts and the respective probability values should be added. So it is very tough to take every number 1, 2, 3, etc. Actually, this random variable, Poisson variable, takes the values 0, 1, 2, 3, etc. up to infinity. Here greater than or equal to means 1, 2, 3, etc. In that same sequence except 0, all the values are included in this case. So if we count the total probability value, it is obviously 1, and take the complementary, subtract the complementary portion, that is probability of x equal to 0, which was already calculated in the subdivision A. So 1 minus 0.1653 gives the answer 0.8347 up to 4 places. So instead of finding a large sequence of numbers, probability values and added, we just take the complementary portion and subtract it from 1, we get 0.8347.